Hi, this is Mrs. Rodriguez, your geometry teacher. This video is a review for the Chapter 13 test that's coming up. These questions are from a practice test that can be found on your textbook on page 969. And what I recommend that you do is that you, when a problem comes up on the screen, pause the video, try to solve the problem yourself, and then play the video, and then listen to my explanation and the solution. And if you get the answer correct, great, move on to the next problem. If you get to the end of the video and there's a few problems that you didn't understand my explanation, or if you got a problem wrong, you don't understand the mistake, please call, text, email me, or stop by my office hours, and I'll be happy to help you. Okay? All right, let's go ahead and get started. Okay. So this is a review for Chapter 13 for geometry. Okay, so first section talks about sample spaces, and it says the sample space of an experiment is a set of all possible outcomes. It can be determined by using an organized list, a table, or a tree diagram. Okay. So here it says a pair of men's shoes comes in all sizes, 5 through 13, in navy, brown, or black. How many different pairs could be selected? So this is an additional practice problem, okay, and you will have one similar to this on your test, okay? So if we can use an organized list or a tree diagram to create the sample space here. So we would have size 5 shoes, size 6, size 7, size 8, 9, 10, 11, 12, and 13. And for each one of those, there is a navy, a brown, and a black. So for each one, you would have a navy, a brown, and a black. So you would have 3 for each one of these if you're doing a tree diagram. So we would end up with, if we added all these together, the navy, the brown, and the black, navy, brown, 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 and black, okay? And we end up with, if we added all these up, we would end up with 27 pairs, okay? All right, so just lesson 2 talks about permutations and combinations. So a permutation of n objects taken r at a time is given by using this n, p, that's p is for permutation and the r, and then a combination of n objects taken r at a time is given by using this formula, okay? So permutations should be used when order is important, and combinations should be used when order is not important, okay? So here it says an engineer is analyzing 3 factors that affect the quality of semiconductors: temperature, humidity, and material selection. There are 6 possible temperature settings, 4 possible humidity settings, and 6 choices of materials. How many combinations of settings are there? Okay, so here we would use the fundamental counting principle. There are 6 temperature settings. So we're multiplying by each possible setting, okay? There are 4 possible humidity settings, and then there are 6 choices of materials. So we would do 6 times 4 times 6, which ends up being 144. So there are 144 combinations, okay? All right, and then we have geometric probability, and it says if a region A contains a region B and a point E, in region A is chosen at random, and the probability that point E is in the region. B is the area of region B over the total area of the region. Okay, so if we had a problem like this, it says point X is chosen at random on AE, so AE is the whole entire segment here. Find the probability of each event. Okay, so we want the probability that X is on AC. Okay, so we're going to have the area of AC, segment AC, over the whole entire segment here, which is AE. Okay, so AC is from here to here, so that's 5 plus 13. Okay, and then the whole segment A to E would be all of these together. So it'd be 5 plus 13 plus 15 plus 7. Okay, so 5 plus 13 is 18, and 5 plus 13 plus 15 plus 7 would be 40. And then we can simplify here. So I would divide by 2 over 2, and 18 divided by 2 is 9, and 40 divided by 2 is 20. We can't simplify anymore. So that would be our 9 over 20 is our probability, or 4500ths, or 45%. Okay, so it'll ask any one of those ways the answer could be presented to you. Okay. So then this problem number 9, says Cordell is shooting a paintball gun at the target. What is the probability that he will shoot the shaded region? Okay, so we need to find the area of that shaded region and then divide it by the area of the whole region. Okay, so we have the area shaded over the whole area. Okay, so recall for area of a circle is equal to pi r squared. So we have pi times the radius, which of the shaded area is 2, and we're squaring that. And then over the whole area of the whole entire circle, so it'd be pi times the radius of the whole circle right here is 5, and we're squaring that. So 2 squared would be 4. We still have to multiply by pi. 5 squared is 25, and we still multiply by 5. So now at this point, we can simplify because pi over pi is equal to 1. So what we're left with is 4 over 25, or we could also write that as 1600ths. Okay. All right. So next problem or next section talks about simulations. So a simulation uses a probability model to recreate a situation again and again so that the likelihood of various outcomes can be estimated. So this is an additional practice problem. It says Darius made 75% of his field goal kicks last season. Design a simulation that can be used to estimate the probability that he will make his first field goal kick this season. Okay, so it says he made 75% of his field goal kicks. Okay, so we need to design a simulation where there's a 75% probability of success and then a 25% probability of failure. Okay, so we can use a spinner. Okay, and we would have 75% be one color and then 25% be another. Okay, so let's say that's 25%, and then this is 75%. And then we have our spinner here. Okay. So this would be our simulation. Okay. So we divided our spinner into two sectors. 75% is one color, the blue, and 25% is another color, the pink. So you could spin the spinner 50 times. Okay. And then each spin represents kicking a field goal. Okay. So each spin represents kicking a field goal. Okay. All right. So here it says, problem number 10, next problem says, what is the probability that a phone number using the number 777, 222, and 6 will be 622-277? Okay, so 7 appears 3 times in this series of numbers. 2 also appears 3 times. And then 6 only appears 1 time. Okay, so this is going to be permutations. This is a permutation. So we would take okay, so this would be 7 factorial over 3 factorial times 3 factorial. We wouldn't do times 1 factorial because that would just be 1. Okay, so then if you type that into your calculator, 7 factorial divided by 3 factorial times 3 factorial, you end up with 140. There's 140 possibilities, but to get this specific number, there's only 1. Okay, so the probability would be 1 out of 140. Okay. All right, problem number 11 says 15 people entered the drawing at the right. Over here it says movie ticket giveaway, enter for a chance to win 3 tickets. What is the probability that Jodi, Dan, and Pilar all won the tickets? Okay, so this would be a combination. Okay, so order does not matter, like in the previous example, order matter, that's why it was a permutation. So it doesn't say Jodi has to win first and then Dan and then Pilar, just these 3 we want them to win. Okay, so we have a combination. There's 15 possibilities and we want 3 winners. Okay, so we would write this as 15 factorial over 15 minus 3 factorial times 3 factorial. So this ends up being 15 factorial over 12 factorial times 3 factorial. You type that in your calculator, you end up with 455. So the probability would be 1 out of 455. Okay, that they would be the winners. All right, number 15 says use a spinner to find each probability. If the spinner lands on the line, it is spun again. Okay, so what is the probability that the pointer will land on red? Okay, so the red section is 90 degrees out of a total 360 degrees. Okay, so if we simplify by 10 over 10, we would end up with 9 over 36. And we could simplify again by 9 over 9, and we would end up with 1/4, okay, or 25%. So the probability of the spinner landing on red would be 1/4 or 25% of the time it would land on red, when you spin this, okay? All right, so probabilities of compound events. So if event A does not affect the outcome of event B, then the events are independent, and the probability of P and A would be multiplying the probability of A times the probability of B, okay? If two events A and B are dependent, then the probability of A and B would be the probability of A times the probability of B over A. And if two events A and B cannot happen at the same time, they're mutually exclusive. So the probability of A or B would be the probability of A plus probability of B. And if two events are not mutually exclusive, then the probability of A and B would be, we would take the probability of A and add the probability of B, but then subtract the probability of A and B. Okay, so here's an additional practice problem. It says two cards are randomly chosen from a standard deck of cards with replacement. So that means they take a card, they put the card right back. What is the probability of successfully drawing in order a 3 and then a queen? Okay, so the probability of getting a 3 and then a queen, okay? So because they are replacing this, they are going to be, they're independent of each other, okay? So we're going to multiply the probability of getting 3. So there are 4 3s in a standard deck of 52 cards. There's a diamond, a heart, a spade, and a club, all of which each one has 1 3, okay? So because they're putting the card back, let's say they got a 3 the first time, they're going to put the card back, and then the probability of getting a queen, there's also 4 queens, and there's still going to be, if they put the card back, there's still 52 cards, okay? So then we're going to multiply. We get 4 times 4, which is 16, and 52 times 52 is 2,704. Okay, and then we could simplify by 16 over 16, and we end up with 1 over 169. So that is the probability of pulling a 3 and then a queen if we put the card back, okay? All right, so here we have a deck of cards, has 5 yellow, 5 pink, 5 and 5 orange cards. So that's a total of 15 cards. 2 cards are chosen from the deck with the replacement. Find the probability of getting a pink. And so with replacement, so they are put back. And then the second one also being pink. Okay. So there are 5 pinks. So that would be 5 out of 15. That's the probability of picking a pink card. Now because they're putting the card back, if it was a pink card, there's still going to be 5 pink cards, and there's still going to be 15 cards altogether. So this would be 25. 25 times 5 is 25, and 15 times 15 is 225. And then we could simplify by 25 over 25, and we would get 1 over 9. Okay. And then number 13 says there are 6 green, 2 red, 2 brown, 4 navy, and 2 purple marbles in a hat. So for a total of 16 marbles. Sadie picks 2 marbles from the hat without replacement. So it means she's not putting the marble back once she grabs one. What is the probability that the first marble is brown and the second marble is not purple? Okay. So the first marble being brown, what's the probability of that happening? Well, there's 2 brown marbles out of a total of 16 marbles. times the probability of getting not a purple marble, okay? So without replacement, right? So there's not putting it back. So we look, and now there's only 15 marbles, right? Now we've got 15 marbles, and how many are not purple? So there's only 2 purple ones. So we would do 15 minus 2 over 15, because now there's only 15 marbles left, right? So we had to find how many non-purple marbles there were. So we took how many marbles were left. So 1 has been pulled out. So now there's only 15 marbles. 2 of those marbles are purple. So we would subtract 2, and that would be 13. And now there's only 15 marbles because they already took out 1 brown marble. Okay, so then we would multiply 2 times 13, and that would be 26. And 16 times 15, that would be 240. And then we would simplify by 2 over 2. So 26 divided by 2 is 13, and 240 divided by 2 is 120. So the probability of getting a brown marble and then not a purple marble would be 13 out of 120. Okay, so thank you so much for watching. Hopefully this video was helpful to you, and it answered a few of your questions or any misconceptions you may have had. If you're at this point in the video and you still had a couple problems or you just didn't understand, please call, text, email me, or stop by my office hours, and I'll be happy to help you. Okay, you have a great day and good luck on your test.